In this video, we are going to learn about multidimensional arrays. Let us first see how declaration will be done for multidimensional arrays. It is similar to declaring single dimensional arrays. We first write the data type, then array name, and then size of the array. So because we are saying these are multidimensional arrays, when we have two different sizes, those are two-dimensional arrays. If we have three sizes, then those will be called as three-dimensional array and so on. So technically you can declare arrays with n number of dimensions. In this example, I have declared an array, named it as myvar, and it is of type integer. It is three-dimensional array. So total number of variables that this array can store is 1 multiplied by 2 multiplied by 3, which will be 6. In this another example, I have declared an integer array with dimension as 2 and 3. So total data size will be 2 multiplied by 3, that is 6. The better way to visualize two-dimensional array is like this. In this table, these are your rows and these are your columns. So in array declaration, 2 is your row and 3 is your column. So array of 2 and 3 is basically 2 rows and 3 columns. If you declare an array of, let's say, int foo 5 and 3, then we are declaring 5 rows and 3 columns. So these are 5 rows and these are 3 columns. Each element is indexed like this. So 0th row and 0th column, 0th row, first column, 0th row, second column, first row, 0th column, first row, first column, first row, second column. Similarly, in this case, it would be 0, 0, 0, 1, 0, 2. Then next row is 1, 0, 1, 1, 1, 2. Then 2, 0, 2, 1, 2, 2, 3, 0, 3, 1, 3, 2. And finally 4, 0, 4, 1, 4, 2. Important point to recollect here is that always index starts from 0. Let us take one more example. In example 2, we are declaring a character array. It's a two-dimensional array. For simpler understanding, we are initializing the variables like this. So this is my first row and this is the second row. Also notice in this case, I have not specified any size. So this is an unsized array. However, the second parameter is compulsory. So you need to at least specify data size of your second size. Now why this is optional? Because as we have initialized the array, so total data size is 10. Just by counting you can identify that. So total elements that we have specified over is 10. So 10 divided by 5 you get 2. So the compiler will automatically understand that this array is of size 2 and 5. Now let us take this third example. When you specify both the size elements, this is called a sized array. In this example, I have initialized this array by specifying values. So again, these are my rows and these individual elements are my columns. You can also initialize arrays like this. Compiler will not throw an error, but it will obviously give you a warning. However, it is always better to initialize your array elements like this. So for you, visualizing values becomes easy. Now let us finally look into how we can access values that are stored into arrays. So here I'm just printing an integer and I'm specifying the value location. So when I say 2, 1, so 2, 1 is this part. So whatever the value which is stored at this array location will be displayed over here. Similarly, if you want to store value at a certain array location, then you can use scanf statement as regular and then specify address, variable name and the location where you want to store those values. So in this case 32, the value entered by user will be stored at this location 32. Similarly, you can assign values like this. So whatever the value that at the location of array 2, 3 will be stored into variable B. So this was all about multidimensional arrays. In the next lecture, we'll check few programs on multidimensional arrays. Now we are going to check few programs on two-dimensional arrays. In the first program for it, we are going to accept a m by n matrix from user and reprint it. As we have seen in the theory lecture that in case of matrices or when we use two-dimensional arrays, these are your rows and these are your columns. So in the program, I have declared a matrix of 5 by 5, that is 5 rows and 5 columns. So technically we have 5 multiplied by 5, 25 integer values that this array can store. Then I'm asking user to enter values of m and n so that he can choose to have matrix of variable size like 3 by 2, 3 by 1 or 4 by 5 and so on, but not more than 5 because maximum size that our array can store is 5 by 5. How to have this dynamic, we'll check that later on, but to keep things simpler, I have created a matrix of 5 by 5 for current scope. So after entering values of m and n, using this code block, we can accept values for all array elements. Suppose user has entered 3 and 3 as values of m and n. So the first loop that will be executed for rows and second loop will be executed for columns. So for every row, this loop will be executed, which will internally iterate through columns. So inside of second for loop, using the scanf, we are going to store values of array elements. So this is your row and this is your column. So the first value that will be scanned will be 0, 0 row. So this is 0th row and this is 0th column. Similarly, 0th row and first column, 0th row and second column, and that will complete your this for loop. So value of I will be incremented and the next row will be scanned. So 1 0, 1 1, 1 2 will be scanned, and similarly in the final iteration 2 0, 2 1 and 2 2 will be scanned. So these are nothing but your array locations that can be accessed using values of I and j as index variables. So whatever user enters in this scanf statement will be stored at this location. So suppose user has entered 10, 20, 30, 40, 50, 60, 70, 80 and 90. So this is my 3 by 3 matrix, and then in order to print the matrix again, we need the similar for loop. So here's the loop for rows, here's the loop for columns, and we're just simply going to print array of ij so that each elements in this sequence 1, 2, 3, 4, 5, 6, 7, 8, 9 will be printed. Notice that after printing a row, I have written /n so that once a row is printed, the cursor will move on to the next line with the help of this /n. So you'll get the complete picture how your matrix will look on the screen. Important thing to notice over here is that asking values from the user, we are using ampersand a of ij, and at the time of printing, we are using simply a of ij. In the next program, we are going to add two m by n matrices. So for the same, I have declared three different matrices A, B and C, and all of them are having size 5 by 5, that is 5 rows and 5 columns. So in the beginning, I am asking user to enter value of m and n. Then this is my first for loop which will accept values for matrix A, and this is the second for loop which will accept values for matrix B. Once that is done, we need to add these matrices into third one. So for adding to matrices, these corresponding values like this and this will be added and stored into this corresponding array element. So we can have the direct for loop that we use for accessing rows and columns, and then we just need to simply write Cij is equal to Aij plus Bij. So all the locations will be looped and individual elements from this array elements will be accessed and stored into corresponding third matrix, that is C. And finally we can print the resultant matrix using the same logic. We'll write for loop for rows, for loop for columns, and then we'll simply print Cij directly. Again we'll use printf /n so that we get the structured printing of matrix, that is after each row a /n will be added, so the new row is printed on the next line. In the next program, we are going to add array elements from a given two-dimensional array. So again, I'm using a 5 by 5 matrix. In addition to it, I'm going to initialize a variable as sum, which will be used to store sum of all the array elements. So again, we are going to perform similar operation. We are going to accept m by n matrix size from the user, and we are going to ask user to enter all matrix elements. Once that is done, we just need to add all the matrix elements. So suppose user has entered 3 by 3 matrices, then all of these values we need to consider for addition. So we'll simply write loop for rows and columns, and then write the statement sum is equal to sum plus a of ij. So all the rows and column will be iterated for performing this sum one by one, and once the addition is performed by this for loop, we will simply print sum of matrix elements is %d, and current value of sum will be printed over here. So assuming user has entered, let's say 1 at all the places, then your final output would be sum of matrix elements is 9, because we had considered that user has entered 3 by 3 matrix, so total 9 elements, and because all the elements are holding 1 as value, so sum of all the elements would be 9. In this lecture, we are going to find addition of main diagonal elements of any given matrix. We have 5 by 5 as a square matrix in this case. So in case of square matrix, wherever row number is equal to column number, all such elements form main diagonal elements. So in case of 5 by 5 matrix that we have over here, these are all 5 main diagonal elements. So 0, 0, 1, 1, 2, 2, 3, 3, 4, 4 are all diagonal elements. So in the program, we need to add all the values present in this diagonal element. elements. So in the logic, I'm asking user to enter value of m because in case of calculating main diagonal elements, the matrix has to be a square matrix. Hence m and n cannot be separate values. So these values must match. So square matrix is a matrix where number of rows and number of columns are equal. So 3 by 3 is a square matrix. However, 4 by 3 is not a square matrix. So because row numbers and column numbers are same, I am accepting single number, that is m, and the same variable m can be used while looping our iterations for rows and columns. So here are our loops. Notice that we have m in both the loops. So after accepting value of m, I am writing my for loops for accepting array elements. So all the array elements will be stored at a of ij, and after that we are going to iterate through the matrix with same rows and columns. And inside of my second loop for columns, I am writing a condition if I is equal to j, that is if my row number is equal to my column number, then we are going to add that number into sum variable. Notice that sum is initialized to 0 at the top. If it is not initialized to 0, it will contain a garbage value and our program will give us incorrect result. And once all elements are iterated using our for loops, then at the end of the loop, I am printing sum of diagonal elements is %d and value of sum will be printed over here. In this lecture, we are going to find addition of upper triangular of a given matrix. So in this image, the area highlighted in light green color is upper triangular matrix. If you notice, a very important pattern with respect to rows and columns is that all the row numbers are less than or equal to column number. So here row and column number is equal. However, here row number is less than column number. So this pattern will be similar everywhere. If we want to do addition of all these numbers, then our condition will be row number less than or equal to column number. So let us see what we have done in the program. We have a 5 by 5 as our square matrix, and again we have sum initialized to 0. I'm asking user to enter m. So those m number of elements will be entered over here and stored into matrix. And finally, for the addition, we are going to iterate across all matrix elements row wise and then column wise. And inside of my loop for columns, I have the condition if I less than or equal to j, that is my row number less than or equal to j. So for all those combinations, wherever this condition holds true, sum will be updated with current value of array element. And finally, when all elements are iterated, I'm finally printing sum of upper triangular elements is %d, and %d will be replaced by final value of sum. In this lecture, we are going to print addition of lower triangular of the given matrix. So what is lower triangular matrix? If you check this image, elements highlighted in light green color are elements of lower triangular. So if you notice a pattern over here, row number is greater than or equal to column number. And this pattern will be true for all the highlighted elements. Hence, the main condition to check when we iterate through the matrix is row number is greater than or equal to column number. So let us see how we can solve this programmatically. I'm using my matrix A of size 5 and 5, and after that I am asking user to enter m. So because it has to be a square matrix, I'm using a single variable again m, and after that I'm asking user to enter array elements. So if user has entered m is equal to 3, then total 3 multiplied by 3, that is equal to total 9 elements will be entered by the user. And then we need to add array elements of lower triangular matrix. So this is our loop here for iterating across all array elements, and inside of my loop for columns, I have added the condition that we discussed over here, that is I greater than or equal to j, that is row number greater than or equal to column number. And inside that, if this condition is true, then we are performing addition over here. So whatever the value of sum is currently, that will be added with current array element that we are iterating. And after when this code block completes, we are finally printing sum of lower triangular elements is %d, and %d will be replaced by sum. In this lecture, we are going to write a program for the multiplication of two matrices. Now, to multiply two matrices, the rules are like this. So this row is used with these elements, and this would be the formula. So you get the first element of resultant matrix, and for the second element, again A, B and F, H will be used, and C and D will again be used with these elements to find this element, and finally again C and D will be used with F and H to form this element. Notice that first element is multiplied with first element of second matrix, then second element of the first matrix is used with second element in the column of second matrix. So these two are multiplied, and then these two are multiplied, and the result is added so that you get this first element. Now before performing this multiplication, there has to be certain conditions that needs to be matched. So if we have two matrices, then suppose both are having sizes as m multiplied by n and m multiplied by n, then number of column of first matrix must match with number of rows of second matrix. For example, if you have two matrices as 2 by 3 and 3 by 2, then here number of columns are matching with number of rows, so it's a valid case for multiplication. However, in the second case, number of column in the first matrix is not matching with number of rows of second matrix, hence multiplication cannot be performed here. Now to keep my explanation only related to multiplication in this program, I'm assuming that we are going to accept a square matrix wherein number of rows will be equal to number of columns in both the matrices. However, from the download sections you can find one extended version of the same program where validations are also checked. So let us continue with the simpler version of the problem. So in the program, I have declared three different matrices A, B and C, all with dimension as 5 by 5, and then I'm going to ask user to enter order of matrix, that is M, because I'm assuming this to be a square matrix. And after M is entered, I'm asking user to enter first matrix, which will be stored into first array, that is A, and then I'm asking user to enter second matrix and all the elements will be stored into B. Now that we have both matrices ready with us, now let us perform our multiplication. So in order to form this matrix, I'm writing standard iterations over here. So number of rows and number of columns will be iterated for the third matrix. I'm initializing Cij with 0 because all the multiplication we are required to add. So I'm initializing it to 0, and then for each operation I will require another for loop. So for each operation of this internal multiplication, I will require another for loop. So I'm using another variable k as index variable over here. Then this will loop from 0 till whatever the value that m has, assuming it to be 2 in this case. So for the current value of Cij, we are taking first element from the first matrix and first element from the second matrix. So that will give me this result, and then in the second iteration of k, second element from both the matrices will be used, and that will give me this element. So these will be my iterations of k. So these two results will be added on each iteration, and that will give me first element of third matrix. The same process will continue for second element, then third element, and then fourth element. And after this multiplication is completely performed, we are going to print resultant matrix using this code block. In this lecture, we are going to print transpose of a given matrix. But before we start writing program for this, let us understand what transpose of our matrix is. Suppose we have a matrix given of size 4 by 5, then 4 are my rows and these are my columns, which is 5. So we just need to replace all the columns with rows. So all the row elements will be converted into column elements. So this will be my first row, which is converted into first column, and second row will be converted into second column, and so on. So if we have a matrix of size 2 by 3, transpose of that matrix will be 3 by 2. So in other words, if you want to just print the given matrix, then suppose we have stored elements like A of ij, then transpose of it will be A of ji. So let us see how we have wrote the instructions for this program. Because transpose can be of any dimension of matrix, it doesn't has to be a square matrix. Hence, I'm asking user to enter m and n, which are used for our number of rows and columns. And once values are m and n are inputted by user, we are asking user to enter values of matrix elements. So if user has entered 2 and 3 as values of m and n, then total 6 array elements will be entered by the user with the help of this code block, and it will be stored at the address location of a, I, j respectively. Now once user has entered all the matrix elements, we are just going to simply print it with the help of our for and j loop for the rows and columns, but instead of printing a of ij, I am writing a of ji. So that will print a transpose matrix.